Right, so we have a nice, interesting question here. Trees, oranges, orchards, harvests, all sorts of things. And as always, we want to pick out what is important and what's not. Okay, so don't worry, we won't even think of a tree diagram. It's too much. Okay, so we've got harvests, right? So there's a harvest 1 and there's a harvest 2. And in a particular harvest, for the oranges that are there in the harvest, we have probabilities of being picked given. So there's a 70% chance, or probability I should say, of being picked in the first harvest. In the second harvest, for the oranges that are there is a 0.35 probability of being picked. In other words, we are kind of told what the probability is of not being picked, or picked like that, not picked. Well, obviously it's just going to be like the opposite, because either it's picked or it's not picked. Binary situation here. So we've got a 0.3 and a 0.65. So if we want to look at not being picked in harvest 1 and not being picked in harvest 2, well, we know that and is like when you look along a tree diagram, this happens and this happens. So in that case, you multiply. So let's follow the same logic, that you can just go 0.3 times 0.65 equals whatever your merry calculator says. Okay, so I explained this earlier and I've stopped because I overcomplicated with tree diagrams, and hopefully you get the same sense now of, wait, either an orange is picked or it's not picked. We're looking at the probability that a random orange is not picked. Well, it must be not picked and not picked. And, well, that's just 0.3 times 0.65. Okay, let me leave it at that. I'll look at the next one, because the next question is convoluted and contrived like so many of these are, but, we have to read through those, and it's not too bad. At least we can picture some oranges and get some orange juice a bit later.